In this video, I'm going to solve the numerical problems on page 69. Let me start with the first example, example 1. What is the potential difference between two terminals of a battery if 56.5 joules of work is required to transfer 50 coulombs of charge from one terminal of the battery to the other? In this question, we are given the amount of work done. The amount of work done is 56.6 joule. 56.6 joule, and the quantity of charge is also given. It is 50 joules or 50 coulombs. Here we are going to calculate the potential difference between the battery. Suppose this is the battery, positive, negative. Negative charges are transferred from negative pole to positive pole. Here the amount of charge transferred is 50 coulomb. The formula is potential difference between the two poles, negative and positive terminals, is V equals to work done by charge. Here work done is 56.6 and the amount of charge is 50 coulomb. Dividing this, 50 divides 56.6. 51 are 50, then 6.6, 51 are 50, 6 minus 0, 6, 6 minus 5, 1, and 0, 50, 3 are, it will be 150. Let us take up to this decimal, 1.13. Then the answer is 1.13 volt. Example 2. Work done in bringing a 3 coulomb of charge from infinity to a point A is 12 joule, and in bringing it to point B is 16 joule within an electric field. Calculate the potential difference between the 2 points A and B. Here we are given 2 points A and B. The work done in bringing the charge to B is more, it is 16. Let this point be at infinity. Here is the source charge. So the work is done against the electric field. This point is closer and work done will be more. So this point will be B and this point will be A. In bringing the charge from A to B, from infinity to point A is 12 joule, from infinity to point B is 16 joule. Then the amount of charge is, Q is 3 coulomb. 3 coulomb of charge is brought from infinity to A and then infinity to B. The potential difference is V, let it be V. It is the work done in bringing, here we can calculate VA and VB first. Potential at point A, what is it? It is the amount of work done per charge. V infinity to A divided by the amount of charge. That is 12 joule. Infinity to A is 12 joule divided by 3 coulomb. That is 3 4s are 12, It is 4 joules. Potential at point B is work done in bringing it from infinity to B divided by Q. Infinity to B is 16 and Q is 3. Let me divide 16 by 3. 3 5s are, oh, this will not be joule, this will be volt. 3 5s are 15, 16 minus 15, 1.03, 3s are 9, and 3, 3. Okay. So VB is 5.33. 5.33 volt. Then the potential difference V is VB minus VA. So 5.33 minus 4.00. Then we get 3 minus 0 is 0, 3 minus 0, 0, 1.33 volt. Question number 3. How much charge is transferred between the terminals of a battery of 20 volt? If amount of work done in transferring the charge from one terminal of the battery to the other. Here the EMF of battery is given, that is 20 volts. That is the potential difference between the two poles. The amount of work done from positive to negative is 100 joule. Then we have formula V equals to W by Q. We are going to calculate Q, that is W by V. Okay. Work done is 100 and the potential difference is V 20. 2 5s are 10. So we get the amount of charge is 5 Coulomb. Then we can go to question number 4. How much energy is given to each Coulomb of charge passing through a 6 volt battery? How much energy? Here the amount of energy is equal to the work done in transferring the charge. We are going to calculate Q, or how much energy it is to calculate. To each Coulomb, it means the amount of charge is 1 Coulomb. Each Coulomb means 1 Coulomb. And the potential difference of the battery, that is 6 volt. And applying the same formula, W equals to V equals to Q, W by Q. Then we are going to calculate W. W is Q into V. So W is equal to Q is 1, V is 6. Then we get 6 joule. So the amount of energy is also 6 joule, because energy and work done are equal. Now let us discuss the in-text question on page 70. In-text number 1. What is the value of an electron? The value of charge on an electron. It is 1.6 into 10 power minus 19 Coulomb. Then the next question is define electrostatic potential. Electrostatic potential, what is its SI unit? Electrostatic potential means electrostatic potential at a point. It is the amount of work done in moving a unit positive charge from infinity to a certain point against the electrostatic field. And the SI unit is volt. Question number 3. Joules per Coulomb. What is joule per Coulomb? Work done by charge. Joule per Coulomb is the unit of which physical quantity? The physical quantity may be potential difference or potential at a point. You can write either potential difference or potential at a point. Question number 4. Name the instrument used for measuring potential difference. It is nothing but a voltmeter. Question number 4, a voltmeter. Question number 5. How many electrons are there in one coulomb of charge? It is 6.25 into 10 power 18. Then question number 6. What is meant by saying the potential at a point is 6 volt? Potential at a point is 6 volt. It means the amount of charge, the amount of work done in moving one coulomb of charge from infinity to this point is 6 joule. Here, potential difference is equal to, or potential at the point is equal to amount of work done in moving a charge from infinity to point A. Then it is divided by Q. Here the potential at the point is 6. V is 6 volt and Q is 1 coulomb. Then what will be W? W will be, W infinity A will be Q into V. Q into V. Q is 1 and V is 6. So it is 6 joule. So we can say that it means the amount of work done in moving one coulomb of charge from infinity to point A, that point is 6 joule.